Okay, we have our third and final page of notes. The last page of notes here focuses on writing the equations of these functions. Okay, now it is good to know, because normally this is what we're going to use, the full form of the equation. So normally for a line, it's y minus y1 equals n times x minus x1. But for this particular worksheet, you're only going to see things in the form y equals a times x. So we just need to find that a value. Same thing for parabolas. Normally we got this big equation, but y equals a times x squared is all you're going to see on this worksheet. Similarly, for a linear absolute value, this is what the equation looks like. But for this worksheet, it's just going to be in this form, y equals absolute value of a times x. And for exponential functions, it's normally this whole equation, but we're only going to see them in this form on this equation. In this worksheet, which is what you saw on your first set of notes. They gave you those forms of the equations here. So we're not going to waste any more time. We'll get right to it and get these answers. Okay, so how do we get the equations of these different graphs? I'll show you how to do it algebraically, and then we'll look at maybe some shortcuts to finish up the last couple examples. All right, so my first one, we've got a linear function. How do I get the equation of that line? Well, I know my equation is going to look something like this. It's going to be y equals some number times x. We just need to find a. So can we solve this equation for a? Yeah, if we know what x and y are. Okay, so then how do we get an x and a y? Well, we've got 2 points, so let's take one of those points and plug it in. Now, normally you don't want to take the 0, 0 point on any of these problems, especially these two. They're going to give you, an equation that doesn't make sense. So pick a point that's not 0, 0. So we got the point over here, -3 comma -1. Okay, hopefully you can read that there, -3 comma -1. So this is my x value, this is my y value, so let's plug those in. So if I stick in y is -1 and x is -3, okay, then now I've got an equation with where my only variable is a, so now I can solve for a. If we divide both sides by -3, then that's going to give me a by itself, and I get a equals -1 divided by -3 is positive 1/3. And then now that I know that a is 1/3, I can plug that in here, and I get my equation, y equals 1/3 times x. And then that's my equation. Okay? All right, let's stick with lines for a second. How could we have got that equation more quickly? Okay, well, since all we need to find is a, well, what does a represent in a line? Well, basically it's my slope, right? In the notes, they refer to it as y equals m times x. Ma doesn't really matter. Maybe I should have used m. But basically all we're looking for is the slope, okay? So I got these 2 points. We'll just count the rise over run. I'm going to go up 1 and to the right 3, up and over to the right. In other words, if it's going uphill, that's a positive slope of up 1 over 3. So then that's my slope. Okay. With this graph here, how can I get the equation without having to do all that algebra? Okay, well, I know it's going to be y equals something times x. I just need to figure out what is my a value. Okay, now first of all, what type of slope is this? From left to right, it's going downhill, so then I know it's a negative number. Okay, and then what is the rise over run? So let's see, from this point to that point, I go up 1, 2, 3, 4, and over 1. So that's going to be -4/1, which is just -4x. And now I've got the equation of that line. Okay, let's stick with the lines here. Last one, let's see, the last one, that's a special case. So it's going left and right, that's like the x's, so is it x equals some number? Well, no. Now, if you need help figuring this out, write down these 2 points. We'll use red, hopefully it stands out a little bit better. So we got -1 comma -3. And over here we've got -1, 2, 3, 4, 5, comma -3. -5, comma -3. All right, so then what do these 2 things have in common? I know it's kind of hard to see, but they both have a y value of -3. In other words, everywhere on this line, what's always true? Well, no matter where I go, y equals -3. So then that's the equation of that horizontal line. So it's actually y equals, not x equals. Okay? All right, so then there's our lines. Next, let's move on to the parabolas. Okay, now again, all we really need to find is the a value. So how can I do that? Well, the same way we did it over here, algebraically, by plugging in another point. Because we know our equation, since our vertex is at the origin, which is going to be the same case on every problem on this worksheet, it's going to look something like this, our equation, y equals something times x squared. So I got an equation with 3 variables. Can I solve for a? Oh yeah, if I know what x and y are. Okay, well if I take a point, that's going to give me an x and a y value. So this point is at 1, 2, 3, comma 2. So we've got the point 3, comma 2. And then that gives me an x and a y value that I can plug into my equation. So I want to stick in y is 2 and x is 3. And then I want to work out that equation. So let's see, to save a little bit of space, little mental math, 3 squared is 9. So then I want to divide both sides by 9 to get a by itself. And then that gives us a equals 2 over 9. And just leave it as a fraction. Okay? And then now I can stick in that value for a here, and I get y equals 2/9 times x squared. Okay? Now, that's how I would recommend doing the parabolas and the absolute value function. Actually, absolute value functions are easier. But that's how I'd recommend doing the parabolas. There is a bit of a shortcut. I'll try to explain it to you, and we'll see if you guys can get it. If not, just do the algebra. Okay? So what's the pattern with a parabola normally? So a normal parabola, I go over 1, up 1 squared. Over 2, up 2 squared. Over 3, up 3 squared. That's the normal pattern. And if I can figure out what I need to multiply by to get that number, so for example here, to get from this point to this point, I go over 1, 2, 3. So normally I go up 3 squared, which is 9. Well, how do I turn that 9 into a 2? I have to multiply by what? Well, the answer is 2 over 9. So if you can figure that out in your head, you can do these a little bit more quickly. Okay? In fact, we're not even going to really bother with the shortcut for the other 2 parabolas. Let's just do it algebraically. So for the next one, well, I know my equation is going to look like this. Y equals something times x squared. I didn't need the parentheses there, but that's okay that they're there. Let's see. So I need to solve for a, so I want to know a value for x and y that I can plug in. Well, let's use this point. So if we plug in that point, 1, 2, 3, 4, so negative 4, comma 1, 2, 3, 4, 5. Negative 4, comma negative 5. Well, then that gives me an x and a y value that I can plug into my equation. So I want to stick in y is negative 5, and x is negative 4. And then I can simplify this. So if we square negative 4, we get positive 16. So I want to divide both sides by positive 16. Now if I had more space, I might write it out. Negative 5 equals 16a, but we're tight on space here. And that gives us a equals negative 5 divided by 16. Just leave it as negative 5/16. And now that I know what a is, I can plug that into my equation, and I get y equals negative 5/16 times x squared. And then that's my equation. Again, not a ton of space to work here, but we can squeeze it in. Okay, now again, normally, if I go over 4, 1, 2, 3, 4, I'd go up 16. Okay, well 16 times what gives me negative 5, because that's where I ended up. It'd be negative 5/16. So if you can do that in your head, then you can, it's a bit of a shortcut. All right, and then the last one, I know my equation is going to look like this. Y equals something times x squared. Now this one, let's actually use the pattern because this one works out nice. It ends up being a whole number. If I go over 2, I should go up how far? Well, 2 squared, which is 4. 1, 2, 3, 4. Well, yeah, that put me right where I'm supposed to be. So then this is the parent function of a parabola. In other words, my a value is 1. So it's just y equals x squared. Now again, there's nothing wrong with plugging in the points here. This would be 2, 4. Stick in 2 for x and 4 for y. And solve algebraically, and you get the same answer. But I think we've seen enough examples. Okay? All right, next. This is one of the easier ones, absolute value functions. Normally they look like this. We're using this equation here because we know our vertex is at the origin. Okay, now the reason that these are easier is because, like we talked about before, these lines here, in other words, the a value is basically just the slope of these lines. Okay, so let's see, I know my equation is going to look like this: y equals some number times the absolute value of x. Okay, I just need to figure out two things. First, is this number positive or negative? And that's just going to be dictated by whether or not my v is opening up or down. And then what's the slope between any 2 points on that line? Okay. Now, again, for your a value being positive or negative, look to see if your v is opening up or down, because one of your lines is always going to have a positive slope, one's always going to have a negative slope. Okay, so positive means it's opening up, negative, like this one, would be opening down. Okay, so let's see. This is going to be y equals, and then, well, what is the slope between these 2 points? I go up 1, 2, 3, 4 over 2. So up 4 over 2 is 4 over 2. 4 divided by 2 is 2. So 2 times the absolute value of x. Okay. Now we don't always want to just use shortcuts like that. I should have done the algebraically on the first one, but let's do it algebraically on the second one. So the second one, very similar. We know it's going to be y equals something times the absolute value of x. Okay. Now, sure, we could probably just get the slope, and we know it's going to be negative since it's opening down, but how can we solve this algebraically? Well, the same way we did these other problems over here. If I plug in a value for x and y, then I can solve for a. And I can plug in a value for x and y as long as I know another point on my graph. So here we got the point 1, 2, 3, 4, comma, negative 2. That gives us an x value of 4 and a y value of negative 2 we can plug in. So let's plug those in. So we get negative 2 equals some a value times the absolute value of 4. Okay. Well, the absolute value of 4 is 4. So this is like negative 2 equals 4a. So we want to divide both sides by 4. So I'm just doing that in our head so we can save a little bit of space. And then we get a equals, well, negative 2 divided by positive 4 is negative 1/2. Okay. So then we can plug that into our equation here for a, and we get y equals negative 1/2 times the absolute value of x. And then does that work? Is the slope actually negative 1/2? Let's see, down 1 over 2, down 1 over 2, and yeah, that puts us right on that point. So it looks good. Okay. So again, we can always solve algebraically. We just need another point on our graph, and we can plug that in for x and y. All right, let's do the shortcut on this one because these aren't that hard. We know it's going to be something like this: y equals a times the absolute value of x. And then, well, what is our slope on this? Now, first of all, we know it's a negative number because it's opening down. And what's the slope between these 2 points? Well, down 1 over 1, down 1 over 1. Well, it's just 1. Do you need to write the 1? No, but you can. Y equals negative the absolute value of x is perfectly fine. If you want to stick a 1 right there, that's perfectly fine too. Okay, so those are our absolute value graphs. Again, you can always solve algebraically by sticking in something for x and y and get those x and y values from a point on your graph. Okay. All right, and then the last one, exponential functions. Well, they're done pretty much the exact same way. All right, so here, we know our equation is going to look something like this. Y equals some number, they call it b for the base, to a power. So it's going to look something like this. And then, well, can we solve for b? Well, sure. Again, if we have a value for x and y. So then we just want to find a point on our graph, not 0, 1, because that's kind of like 0, 0. We want to find another point on our graph. So let's use this one over here. So we got 1, 2, 3, comma, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I'm sorry. I started from too high. 1, 2, 3, 4, 5, 6, 7. It is 8, isn't it? Yep. 3, comma, 8. Okay. Oh, yeah, that's correct. I'm sorry. Anyways, moving on. Here's an x value and a y value you can plug into our equation. So we get 8 equals some base raised to the 3rd power. Now, we can take the cube root of both sides, but we haven't really done much of this. So just kind of think, what number raised to the third power is 8? So what times itself 3 times is 8? Well, the answer is 2, so we know the base is 2. So then our equation is y equals 2 to the x. Okay? All right, and then yeah, that should make sense because when x is 3, that means our exponent is 3. So what cubed is 8? 2. How about the next one? Y equals something to the x. Well, what raised to the third power is 27? 3, right? So we know this is just going to be y equals 3 to the x. Okay, what about the next one? So we're going to go kind of fast through these ones. Y equals, and it's going to be something raised to the power of x. Well, what raised to the second power is 100 because the x value is always our exponent. The y value is our answer. So what squared is 100? Well, 10. So this one's just y equals 10 to the x. Okay. Now, like I said before, if you have questions, let me know. But I think that wraps up the first set of notes for this unit.